Hello everyone, welcome to the lecture series of the subject code Digital Electronics KOE 039, and this syllabus is as per the AKGEC syllabus scheme, which is covered by the mainly CS branch, civil branch, mechanical, EC and EI. This digital electronics is covered in all these branches. So this is the second year syllabus, and the topic which we are going to discuss today is the tabular method, that is also known as Quine Mccluskey method. Quine Mccluskey method. So till now we believe that you have gone through the min terms, that how we can calculate the min terms, how we can write the sum of product equations. K-map you have studied, and you must know about these terms, that are implicant, prime implicant and essential prime implicants, right? So the K-maps, generally we can use these K-maps to solve the variables up to 3 or 4 variables, and the more if variables are more than 4 variables, or more than 4 variables, we can use this tabular method to solve the circuit. This tabular method is invented by the Quine Mccluskey. It is initially invented by the Quine, and then it is further improved by the Mccluskey. These are the name of two scientists. So this tabular method is named as Quine Mccluskey method. So for the function of 4, 5 or more variables, it is difficult to be sure that the best selection is made. So in such cases, the tabular method can be used to overcome such difficulties. The tabular method was first formulated by this Quine, and it is further improved by Mccluskey. So that is why it is known as Quine Mccluskey method. This Quine Mccluskey algorithm is a method used for the minimization of Boolean function. So this method can be used to minimize the Boolean function, and so that we can have the minimum hardware at the as a circuit. So it is functionally identical to K-maps, but the tabular form makes it more efficient to use in the form of algorithm. So this method is used to design the algorithms which can be used for the Boolean to drive the Boolean expression for the more variables. It also gives a deterministic way to check that the minimum form of Boolean function has been reached. So this method involves the 2 steps. The first step is the prime implicant of the function, and we are going to use these prime implicants in a prime implicant chart to find the essential prime implicants. Okay, so we are going to find the essential prime implicant from the prime implicant chart. So as well as the other prime implicants that are necessary, we will make sure that all the prime implicants are covered in this tabular method. So before starting the tabular method, let us go through these definitions once. Implicant in a Boolean logic function, your implicant is a covering of one or more minterm in a sum of product or product of sum of a Boolean function, or we can say that the group of ones is known as implicant. The prime implicant is defined as a function which cannot be covered by any other group, and the essential prime implicant is defined as having at least one minterm that cannot be combined in any other way. So let us start this example. We have the 4 variable. I am taking this 4 variable example. We have the 4 variables. This will be your MSB, and this will be defined as LSB, and this states that we have the minterms at all these places, right? The output at all these places, we have output at all these places is equal to 1, right? So the first step is write all the minterms and their binary representation. So we are going to represent it in a binary form. So we have 0, 0, 0, 0 for 1, 0, 0, 0, 1 for 3, 0, 0, 1, 1, 7, 0, 1, 1, 1, 8, 1, 0, 0, 0, 9, 1, 0, 0, 1, 11, 1, 0, 1, 1, and 15 we can write it as 1, 1, 1, 1, right? So all the min terms are represented in binary. Next we are going to divide them into groups. The groups can be made by the number of ones present in each group. For example, this first group, your G1 will be your min term 0. It has no variable as a 1. So this will be my first group, 0 group. Okay, so I'll name it as G0. Then in the first group, your number of 1 should be 1. In G1 group, number of 1 should be 1. So at this, in this min term 1, we have single 1. So I'll write it here, 0, 0, 0, 1. Any other min term? So this 8, okay, this 8, 1, 0, 0, 0. All these two min terms has a single 1. Similarly, this is my group 1. Then group 2 will have number of 1s is equal to 2. So I'm going to pair this 3, min term 3, 0, 0, 1, 1. This is done, and 9, 0, 1, 0, 0, 1, right? We have this group 2. Then group 3 will contain number of 1s 3 in any min term. So we have this 7, 0, 1, 1, 1, and 11, 1, 0, 1, 1, and lastly I have the group 4, which has number of 1s is equal to 4, right? So I have divided these min terms in a way that each group will have the equal number of 1s, right? Each group will have the equal number of 1s. So write the min terms here: M0, M1, M4, M3, M9, M7, M11, and M15, right? So next is here group. Under this we are going to compare these two groups. Your group 0 will be compared with group 1, then group 1 will be compared with group 2, then group 2 will be compared with group 3, and this process will go on. So all these variables, all these min terms present in group 0, that will be compared with the min terms present in group 1. So when we compare this M0 with M1, M0 and M1, if I compare these two, if I check these values are same and these this value can be removed. So I can matched pair will be, so here your matched pair will be M0, which is, it is compared with M1, and I'll have the value 0, 0, 0 and dash. The last D variable I have removed, right? I have removed. So next M0, I'm going to compare with this, sorry, it is not 4, it is 8. It is 8. I'm going to compare it with 8. M0 is compared with M8, and by comparing these two, we can see that these three values are same, B, C, D values are same, and this and this are different. So I can remove this. So I can write it as A, I have removed 0, 0, 0, right? So in this way, we are going to compare all these values. This is for my group 0. Okay. Next, all the values, all the min terms of group 0 and group 1 are compared. So this group is done. Group 0 is done, right? Next, for group 1, I am going to compare group 1 with the min terms of group 2. So M1 and M3, compare M1 and M3, we will have 0, 0, C is removed, and then 1. Next, M1 and M9 will be compared, and we will have A will be removed, 0, 0, 1, 0, 0, 1. Next, in the next case, M8 and M9 will be compared. We are going to compare these two, M8, M9, and we are going to remove from these two values. Your D will be removed. Rest 3 variables are same. So 1, 0, 0, D is removed. Okay. So group 1 is now done. Group 1 is now done. Next, we are going to compare group 2 and group 3. So compare M3 with M7. We are going to have the value B will be removed, 1, 1, M3, M11 will be removed, M11, A will be removed, and we will have 0, 1, 1. Then compare M9 with M11, we are going to have 1, 0, C will be removed, and 1. So this complete group is done. Next, we are going to compare group 3 and group 4. Compare M7 with M15. When we compare this M7 with M15, these 3 variables are same. I can remove this A variable. So I'll have A is removed, 1, 1, 1. Then M11 and M15, I will have 1, B will be removed, 1, 1. Okay. So I'll have 1, B will be removed, and 1, 1. So in this way, this is the first step. In the second step, we are going to compare these two groups, then these two, and then these two groups. And we are going to remove 2 variables now. Till now, we have removed a single variable, right? In each term, single variable is removed. You can see that single variable is removed. So till now, we have covered this one in the previous slide. So in the next step, we are going to compare these two groups. Group 0 will be compared with group 1. So here M0, M1, this min term will be compared with M8, M9. And we are going to have, when we compare this, we are going to have A will be removed, A and D will be removed. When this 0, 1, this here, now I am going to compare M0 and M8 with M1 and M9. M1 and M9. Okay. So these two is already removed, right? These two values are same. So this is already removed. These two values are already same, and so these two are different. It will be removed. Fine. So it will be removed. So next is, we cannot compare this M0, M8 with M8 and M9. Right, because your this removed variable is not at the same place, so we cannot compare this. Okay. So next, group 1 will be compared with group 2. Compare M1, M3 with M9, M11. We are going to have the values. A will be removed, 0 and 1. Similarly, by comparing these two, let us check these two values, M1, M9. Here we have the M1, M9. Okay. And M3, M11. M1, M9 and M3, M11. Okay. So by comparing these two, we are going to have 0 and 1, right? Next, under these two groups, when we compare these two groups, we are going to have, when we compare this M3, M7 and M11 and M15, we are going to have the values. A, B will be removed and 1, 1. Then, when M3, M11 is compared with 7 and 15, sorry, it is 15, we are going to have the values. Okay. So this way, we have removed the two variables. So from these two, we have the prime implicants B bar, C bar. Here I'll have B bar, D, and here I'll have C, D. And let us mark all the variables that are used in this stage. So we have used this M1, M0, M1, M0, M8 is used. Okay, M1, M3 is used, M1, M9 is used, then M3, M7, M3, M11, M9, M11, 9, 11, 7, 15, 7, 15 we have used, 11, 15 and 11, 15 we have also used. So tick all the min terms that are used in the next stage, right? So next step is, again we are going to compare this group with this group, this group with this group. The basic approach is check whether any other variables can be removed or not. So if not, if we cannot remove more variables, we cannot compare more variables, we are going to draw this prime implicant chart, prime implicant table. So this is drawn in such a way that first write all the min terms which are present in the question. Okay. Then BC, and which are the min terms which are involved in calculating the B bar, C bar. So here in the B bar, C bar, we can see that min term 0, 1, 8, 9. 0, 1, 8 and 9 are used, right? So under this 0, 1, 8 and 9, we will make the cross. Okay. Then B bar D. B bar D is used by min terms 1, 3, 9 and 11. 1, 3, 9 and 11. Okay. So 1, 3, 9, 11, right? So we have marked these. Min terms. Then CD. To write a CD, we have used 3, 7, 11 and 15. So, mark 3, 7, 11 and 15. Fine. So, your result will be written as, first mark the individual x in any column, right. So, here in this table we can see that this x is individual in a column, right. So, this is correspond to CD. So, this will be my essential prime implicant. So, your y will be written as CD plus, next we are going to have, so this 7 is done. Now, we are going to cover all these terms. So we will pair these and these, okay. These two we can pair. CD I have already paired. So, under this CD, it has, it will also cover this 3, minterm 3, 11 and 15. So, my 3, 11, 15 and 7 are covered under CD, right. So, these all these are covered, and rest of the minterms are covered by B bar, C bar. So, this will be my final result. You can verify this result with the help of K-map also, okay. You can cross check this, solve this with the help of K-map, and you will get the same answer, okay. So, once again I will repeat, first mark the individual x, that will be your essential prime implicant, and this x to it is correspond to CD, right. It is correspond to CD. To cover this CD will also cover the minterms 3, 11 and 15. So, my 3, 7, 11 and 15 minterms are covered under CD, and the rest 1, 0, 1, 8 and 9 are covered by B bar, C bar. So, my final equation will be written as CD plus B bar, C bar. So, let us take one more example if you have some don't care in the question. So, suppose I have the equation y is equal to y is a function of a, b, c, d with the minterms on these places and don't care at these places, okay. So, the process is same, the process is going to be same. We write all the minterms, we have written all the minterms and don't cares, okay. Write it in a binary representation, their binary representation is written. Divide these minterms including don't cares in a group in such a way that each group will have the same number of ones. So, group 1, it will contain single one, right. Group 2 contain number of ones is equal to 2, okay. Group 3, it contains number of ones is equal to 3, okay. And group 4, I have number of ones is equal to 4, okay. So, write the minterms correspond to these two. This is M4, M2, M6, M9, M10, M12, M11, M13 and M15. Till now we are using the don't cares in this. So, now we are going to compare group 1 with the group 2. Compare group 1 with the group 2. When you compare this 4 with 6, compare 4 with 6. So, we can see that this is same, these values are same, right. So, I can write it as 0, 1, this C variable is removed and 0, right. Next, by comparing 4 and 12, your A will be removed and we are going to have B, C bar, D bar. Similarly, compare 2 and 6, 2 and 10. Next, we are going to compare group 2 with the group 3. Compare 9, 11, we are going to have 1, 0, C will be removed and 1. Compare 9 and 13, we are going to have 1, B will be removed, 0 and 1. Similarly, compare 10 and 11. So, this way we are going to complete the chart. Lastly, we are going to compare group 3 with the group 4. 11 and 15, here I have the 15, sorry, 11 and 15 will be compared, and we are going to have 1, B will be removed, 1, 1, and then 1, 1, C will be removed and 1. Okay. So, by removing this, the next step is, compare the next two tables. Till now we have done, now we are going to compare this group with this group by taking the, now we have to remove the two variables. So, we cannot find any, remove any variables from these two groups. So, we are going to compare these two groups next, and we are going to compare 9, 13 with 11, 15. So, we have 1, okay, 1 B and C will be removed, 1, and then 1 B and C will be removed. Okay. So, this way we are going to complete this table. And lastly, in the prime implicant table, you just need to remember one thing, that we are not going to remove the don't cares here. Do not include don't cares here. Okay. So, first write all the terms which are not used in the last step. So, these are the terms which are not used in the last step. Okay. And these are the only terms which we have used in the last step. Okay. So, this 4 and 6, 4, 6 can be written as A bar, B, D bar. So, I have written A bar, B, D bar. Okay. Then 4 and 12, 4 and 12 is not used. I have B, C bar, D bar. So, here I have written B, C bar, D bar. So, in this way, we are going to complete all these values. Okay. 9, 11 is used. 9, 11 is used here. Okay. And 13, 15 is also used here. Okay. So, these 4 are used, rest of the values we will include. And lastly, from this table, we are going to have A, D. So, lastly, we are going to have this A, D. Okay. So, now mark all the terms involved under these values. For 4 and 6, I have marked 4 and 6. Then 4 and 12, 12 is don't care. So, you don't have to worry about that. Then 2 and 6, 2 is don't care, 6 is marked. 2, 10, 2 is don't care, 10 is marked. Then similarly, we have marked all the x under these terms. Fine. So, next we have to find out the individual x in any column. So, here I can see that I have this individual x. So, your equation will include the AD first. Okay. Now, to write this AD, term 9, 11 and 13 are already used. Okay. So, this pair is already done. This complete is already done. So, 9, 11 and 13 terms are already done. Now, I have to include 4, 6 and 10. 4 and 6 to include this, 4 and 6, 4 is in this and 6 is in this. But this pair A bar, B, D bar, it includes both 4 and 6. So, I write A bar, B, D bar. Similarly, here, so these two are done. Now, 10 is covered under this and under this also. So, we are going to include the maximum variables. So, we are going to write A, B bar, C. So, in this way, we are going to solve the tabular method. The only difference is we don't have to include the don't cares in the last prime implicant table. Thank you so much for the lecture.